This continues our lecture on the last section of Chapter 4. We are going to do some word problems that revolve around formulas. An architect designs a rectangular flower garden where the width is 78 feet. So we're going to put in here 78 feet for our width. So 78, and we're going to put that as feet so we don't forget. And if 260 feet of antique picket fencing is to be used to enclose the garden, find the length of the garden. Well, if we're going to enclose the garden, that tells us that we are looking for the perimeter. And we need to know that the perimeter formula for this garden is 2 times the length plus 2 times the width. And we know that the antique fencing is equal to 260 feet. So we're going to put that in right here. And that means that we have something missing. We have the length missing. And so we're going to make that length a variable. And I'm going to use X, not L, because L's are very confusing in terms of variable uses. They look like a 1 a lot of times. And now we're going to use substitution. So our perimeter formula says 2 times whatever the length is. Well, the length is X, so I'll put that in. Plus 2 times the width. Well, the width is 78, so 2 times 78, and I'll use parentheses around the 78 to mean multiplication, and that's equal to 260. And now we see an algebraic equation that needs to be solved, so we'll solve it. So 2 times 78, that's going to give us 156, so we'll simplify that. And 2x plus 156 is equal to 260. The next thing, of course, we need to do is use the addition property to move the 156 to the other side, so minus 156 here. And now what we have is 2x is equal to, and what we have is 260 minus 156, so I'm going to do some borrowing. And then subtracting. 10 minus 6 is 4, 5 minus 5 is 0, and 2 minus 1 is 1. And now I'm going to multiply by the reciprocal here, 1/2, to get rid of this numeric coefficient. And of course that looks like division because it is. And that gives us the fact that our x is equal to 2 goes into 10 5 times, and 2 goes into 4 2 times. And so that means that our length is 52, and then of course we need units on that, so it's 52 feet. And that's our answer. And so we would box that and say that that was our answer. Our next problem, we're going to use the formula for temperature conversion. So it says if it is 52 degrees Fahrenheit, and you see I've already put that in here, what is the temperature to the nearest degrees in Celsius? So degrees Celsius is equal to 5/9 times, in parentheses, the degrees Fahrenheit minus 32. So we're just going to substitute into this formula. So we have 5/9 in our Fahrenheit degrees, which is 52, minus 32, and that simply gives us an order of operations problem to find degrees Celsius. So 52 minus 32 is what's going to come first, so 52 minus 32, that's going to give us 20, and then we have 20 times 5/9. This is going to be rounded to the nearest nearest degree, so we have 20 over 1, 5 times 20, which is going to give us 100. And then that's divided by 9, and so this is going to give us approximately, and 9 will go into 10 one time with 1 left over, and 9 will go into 10 one time with 1 left over, and so that is 11 1/9 degrees. And so again, that's not actually approximately, that's what it's equal to, and therefore approximately rounded to the nearest degree, that would be 11 degrees, and that is Celsius. All right, that'll wrap it up for this particular instance. I'm going to go ahead and end this, and I will start example number 38 in the next lecture.